And the little subheading here is the area of combined polygons. Or if you're not a farmer, it's area of combined polygons. Any farmers? Anybody live off the land here? Farmers? Farmers, anybody?
I grow on this.
My dad does. My grandpa does.
We grow carrots.
We grow carrots.
And apples and bananas.
I grew.
Here's your example, children. Draw this to the best of your 7th grade ability, which I know is not much. What do we got? 6, 4, and 8. 6, 4, and 8. Let's go, let's do inches because I can make those little hash marks. Find the area. Now there is a formula for a trapezoid, but we're not going to do it yet because we're going to do this first. How do you find the area of that? Because we don't have that as one of our formulas. Anybody? Yes, good idea. What I like to do is call this, what you need to do is divide and conquer. Spell that right? Yeah, right? Divide and conquer. Which means, think of the shapes that you do know. Cut the shape into shapes you can find the area of and add together. Give you a chance to write that before we get all crazy here. And I think you'll like this because it gives you a chance sometimes to write 2 formulas down, Joseph, not just 1. Wouldn't that be exciting?
Yes.
And I will tell you, this is the beginning of your mathematical journeys. It's always good to organize yourself when you do these, because multiple step problems cause you trouble because you'll do one step and then think you've done it all and you've actually forgotten something. So this shape right here, what am I going to cut it into? I am going to cut it, draw a nice little straight line down here. We've got this rectangle and we've got this triangle. And you're going to find their areas and simply add them together. Area of the rectangle is what? Now make sure, children, when you do this, you use the right dimensions. Notice this rectangle is from here to here. 8 goes all the way across, so you would not use 8. You'd have to use 6 times 4. And 6 times 4 is 24. That, ladies and gentlemen, is your area of the rectangle. Then you get to the triangle. Area of a triangle is 1/2 base times height, right? Yes. What's my base and my height of that triangle? Here's where, Caleb Fisher, you may have to use some 7th grade mathematical knowledge. And again, 8 is not the base of the triangle. The base of the triangle is right here. And the height could be right here. There's your triangle. How long is my height or my base, Caleb?
4 inches.
How did you get 4?
Half of 8 is 4 and the triangle is 12.
No. Unfortunately, my little shape is not drawn to scale. Hazards. Knowing, Caleb, look, see this was 6 from here to here. That's 6 from here to here. How long does this piece have to be?
2.
2. So the triangle has a base of 2 and a height of 4. So it's 1/2 of 4 times 2. Half of 8 is 4 for the triangle. So the total area would be of the combined thing 28 inches squared. Did I do that right? Maya, did I get that right? According to your, did I use those? And that's why, Caleb, again, when you sketch this on your paper, you probably don't draw two exact dimensions either. So you can't just look at something and say, well, that looks like half. You know, you have to have some concrete evidence because otherwise you're just gonna get a lot of stuff wrong. Now, you ready for a really hard one?
Yes, Mr. Hunt.
I was hoping so. I'm not sure they have a really hard one.
Oh,
Oh, sure they do.
yay.
It looks to me like they're all, looks like to me like they're all pretty simple here. Nope, we're gonna write down a different one. Hold on, write this down. Here is a new shape that's very exciting.
Yay. Yeah.
It's amazing.
That's nice.
A, B, C, D, E. A, B, C, D, E. Are you with me on that?
Yeah.
And this is what you need to write down. AD is 40 centimeters. DC is 30 centimeters. Point B is the midpoint of AC. Oh, great, another error. Point B is mid of AC. Find the perimeter of BCDE. Meter of BCDE. I'm gonna let you write that down and then I'm gonna do a little finagle in here. Wow, did I do something you could not read?
No, can't we just use the Pythagorean theorem? Like if it's 40 centimeters from A to B and then D to C is 30. Divide.
I got to explaining the problem yet? Are you trying to steal my thunder?
Caleb,
I don't know,
why are you doing this?
honestly. Can I not just explain what's going on
You're
here?
such a good
Here's what we're gonna do before we even go into that. I'm gonna move this because, and I don't wanna do that. Let me get something smaller here. I'm gonna get rid of this line right here and move it where it belongs. Which means this. This said midpoint, so I probably should have put it right there, just to make, so Caleb doesn't get confused.
He's always
Throwing it in there. Now, how should you tackle this problem on your paper? First of all, if this is the problem, you will write this down and you will write this down. Then, your next step would be write down all the stuff you know, put all the dimensions on your triangle so you know AD is 40 centimeters, so make sure you label that as such. AD is 40, DC is 30. You need somehow, ladies and gentlemen, to figure out, your ultimate goal is to find what the perimeter of this shape right here. Well, you know this, correct? And that really is all that you know, is it not?
Yes.
And this, by the way, if you like this, this is really what kind of geometry gets into. Now, Caleb Fisher shot at us. We can figure this one out, right? Because of the Pythagorean theorem. Is there a 30, 40 something triangle?
Yeah.
There is.
Well, no, but you can reduce it.
Right. I'll draw it over here so we don't mess up our figure here. This was 40. This was 30. If you divide them by 10, you get a 3, 4. What triangle? 5. So that means, what does the long side have to be?
50.
Right, you have to multiply by 10. So this whole thing is 80. Which means this has to be from here to here, what? 25, right? Because it said B was the midpoint. It's halfway there. Now, how do I know how long DE is? Now, you can't just say because it looks like it. You cannot tell me that E is the midpoint because it looks like E, because it doesn't tell me that E is the midpoint. Here is what separates the thinkers from Abe Lincoln. Lauren.
It says that point B is in the middle.
Right, but that doesn't tell me what this is.
So then that would be in the middle.
That, no, you can't. That is an assumption you cannot make. You have to be able to prove. It probably is, Lauren, but you have to be able to prove it. That's the thing with geometry. Just like Caleb when he looked at that last thing and said, well, that looks like it's in the middle, so I'm going to call it half. Anybody? Anybody? Sittler.
Okay. You have to cut the bottom portion into a square and a triangle. Probably.
Yeah, but even if I do that, I don't know what this is, nor do I know what that is.
Well, when you find it out,
How can you find it out?
you find the area of the triangle. That's what
Area of what triangle?
you cut it. I don't know. I just thought it would work.
But you don't know these dimensions. Okay, I can do this, but I don't have any idea what this dimension is. Come on, thinkers. If anybody actually gets this, I will promise only to give you the assignment I was going to give you anyway. Connor?
20?
Huh?
20?
But why? I agree. In the end, it's probably going to be 20, but in math, you can't just say, I think it's 20. You have to be able to say why. Anybody out there, please, somebody, somewhere, sing the song. Somewhere out there. Somewhere out there. What is that from?
I don't know.
No.
Neutral. I don't know. I just.
Well, let's think about this, children. Okay, this goes back to something we talked about last week. What we've got here are a couple similar triangles. How do I know they're similar? Well, maybe I don't know
Because
they're
they
similar.
make a right.
If you redrew these triangles, yeah, I do know they're similar. Did it say that? Oh, because the book gave this as right angles. Take a look. Here we go. Here's the ooh and ah moment. There may be singing, there may be not. I don't know. We'll see if anybody catches this. Take a look. See. Look.
Come on, Zach.
I got this triangle here, right? I am going to draw it right here. Correct? Same triangle. Got a little bigger. Then I've got this triangle right here. Big one.
Yeah.
Correct?
Yeah.
Here's my big one. How do I know that they're similar? For what reason? Layton,
Because they're diagonal.
how do I know that there were two reasons we gave that we know triangles are similar. Lauren?
Because that side's cut in half.
Aaron?
The sides in portion.
How do I know this? Zach?
The side, the triangle is just the origin.
It is, but see, in math you can't just say that. It is in the end going to be true. You have to give proof. Similar triangles. I'll give you a clue. You either did do, or it would do. Anybody remember what those were? Shannon!
They have corresponding side lengths and corresponding angles.
Well, they have the angles. We don't know about the sides. We have a lot of question marks on angles. But look, angle A, this is A, right? That's the same angle on both, correct?
Yes.
They both have a right angle on the corner, right?
Yes.
So there's no way that the third angle can't be alike because all triangles have 180-degree angles. So, if we know they're similar, children, take a look-see. I know that the long side here on AC is 50, right?
Yes.
And I know that this part from here to here is
25.
25, which means this triangle, to go from this triangle to this triangle, you just do what? Divide by 2. So if this whole side on the bottom was 30, then this side is
Oh!
15. If this whole side is 40, then this side is
20.
20. And yes, it's true what you were saying, but you can't just say that, Matt. I know that this is 20, so that means this has to be 20. And I already figured out this on the bottom has to be 15. So here is where everybody would write all that down and get the problem wrong. Why, Lauren? Because we didn't answer the question. What was the question that the book asked us? So you don't even remember. We got so far into this problem. Yes, and that's part of your goal, people, is when you do this, that's why you should write this down. Because I can tell you, it takes so long in math to get to the parts that you can answer the problem, you forget what the question of the problem was to begin with. The question asked, what is the perimeter of this shape? And the perimeter is 15 plus 20 plus 30 plus 25, which everybody knows is 80, is it not?
Yes.
Nobody's questioning me on that?
No.
Well, I am. Did you question me on that? It's holding down the base section.
Shake it up, baby, now.
Shake it up, baby.
That is, I know, Zach, I like it better when you do it.
Yeah.
Yeah, Zach, you should do it.
Come on, Zach.
Can we try it over again?
Yeah, Zach, you should totally do it.
All right, enough of me talking. If you didn't quite get this, don't worry, you are in the majority of just about everybody who does this.